Good afternoon, everyone, and welcome to our third and final webinar in the Lake Champlain Committee and Tetra Tech Benthic Cyanobacteria webinar series. My name is Lindsay Cookson. I'm the Water Science and Program Coordinator with the Lake Champlain Committee, and I'd like to thank everyone who's joined us throughout the series. We hope the presentations have provided new insights and identification, ecology, and management information of this increasingly important topic. As with our previous webinars, the series has been made possible through funding from the Lake Champlain Basin Program, and we're continually grateful for their support. Before we begin, just a few housekeeping notes. Today's presentation will last about 30 minutes and will be followed up for questions and discussion afterwards. You're welcome to submit your questions throughout the presentation using the chat feature, and I'll answer as many as possible at the end. The webinar is being recorded and will be posted on the Lake Champlain Committee's website and YouTube channel following the presentation. I will be following up with an email later this week with all three webinar links listed out so you can go back and watch any of them. And that will also be going out to our entire monitoring program as well. So it is my pleasure to introduce today's speaker, Jim Coleman. Jim is the Climate Effects Specialist for Investigations, Planning, and Preparedness with the Benton-Franklin Health District in Washington State. Today he'll be presenting identifications and characterization of benthic algae in the Columbia River, Hanford Reach, in Washington State. Jim, thank you so much for being here today. I will turn it over to you, and I'll let Alexis share her screen.
Great. Thanks for inviting me. I really enjoyed the last presentation. Wasn't able to see the first presentation, but I really feel like this is an important and sort of poorly understood topic. So I'm really glad that you guys are doing this seminar series. So next slide, please. So just a little bit of a geography lesson here. If you're not familiar with Washington State, the Columbia River actually starts up in British Columbia, runs north and south through the state, and then as it approaches the bottom of the state, it runs from east to west and terminates in the Pacific Ocean. And it's a very huge river system. It has multiple dams on it, which change the characteristics of the river greatly. It's almost a series of reservoirs in certain parts of the river. And at this point, I'd like to point out that my research focuses on this area in Washington State, sort of southeast Washington, a place we call the Tri-Cities. Richland and Kennewick are shown here, but there's a third city, Pasco, that's not shown here. And this is the focus of my research. And this particular part of the Columbia River is referred to as the Hanford Reach. And it is also referred to as one of the last free-flowing stretches of the Columbia River. As I mentioned before, there's multiple dams on the river, which make it kind of more like a reservoir and not a river. But this stretch that I study is actually a kind of a free-flowing river with cobblestone shorelines. I would like to point out that I'm not the only, or we're not the only group doing research on benthics on the Columbia River in Washington State. To the north, the Corps of Engineers is studying a portion of the Columbia that is in between Grand Coulee Dam and Chief Joseph Dam. And they're doing some very interesting research. Unfortunately, they haven't released much of their findings yet, but I hope that they'll be releasing some research, some of their findings in the near future. Likewise, mostly the USGS has done some work lower on the Columbia, and basically in both of these locations have identified benthics and quite a few different types of toxins, primarily anatoxin. And so there is other work going on in the Columbia, and there may be other work as well, but those are the two other groups that I know that are performing research on the Columbia. So next slide, please. So here's more of a zoomed in version of the previous map. I would like to point out that in the Tri-City area, there are a couple other major rivers that flow into the Columbia. There's the Yakima River, which is a fairly small river. And then there's another major river, the Snake River, that also flows into the Columbia nearby. We have not really investigated the benthics on either river very much, but it does not appear, we sort of have taken toxin readings in the Yakima, and we're not detecting much toxins in the Yakima. The Snake River is kind of interesting in that it has more of a planktonic bloom and less of a benthic problem. But we have not explored that issue very much. The organization that I work for is a bi-county health district, and a portion of the Snake River is in Franklin County, but most of the parts where they're having planktonic blooms are outside of our county. So I have not really investigated the Snake River very much. I would like to point out with this map here that the three major cities, Kennewick, Pasco, and Kennewick, all use the surface water from the Columbia River as their main drinking water source. So the fact that we are detecting anatoxins in the Columbia River in surface water is a bit concerning because there is the potential for drinking water to be impacted. Next slide, please. So here's a great aerial photo of part of the study site. In this region where you see a big reservoir, that is a reservoir behind this dam, which is called the Priest Rapids Dam. And then you can see that the river characteristic changes greatly. It's much narrow and the current is much swifter. And it's this portion below the Priest Rapids Dam that we're studying, and we're actually finding the worst benthic growth in this very fast moving stretch of the river. I would like to point out at this time too is that most people envision Washington as the evergreen state with lots of green growth, but the eastern portion of Washington state is actually part of the Great Basin Desert. So it's very arid, and our ambient temperatures can get quite high. As a matter of fact, I think it's going to be over 100 degrees today. So kind of an arid region. Next slide, please. So hopefully not being overly obvious here, but our introduction, and when I say our introduction, the health district where I work, our first introduction with harmful algal blooms was in a reservoir nearby. And you have these planktonic blooms, which are very obvious, of course, and there's this strong visual clue that you know something's wrong. And general people in the public that would visit a lake like this would also deduce that there's a problem here and probably report it to their health jurisdiction. Whereas the benthics, when they grow on substrates on the bottom of the river, they're less obvious and they just kind of look like slime that's growing on the rocks, and less people would think that they pose a health hazard. And that's essentially why we're meeting today, is because the benthics are a little less understood and yet still produce toxins that can be harmful. Next slide, please. So a term some people aren't familiar with is periphyton, and that's just the material that's growing on surfaces, substrates in the water like rocks, could be submerged wood, could also be sand. Anyway, it's dominated by microalgae that often form these long filaments and sheets that cover over the sediments. And it can be a very complex, excuse me, a very complex community of algae, bacteria, fungi, and a variety of invertebrates. And this is just a nice snapshot of kind of what we see in the Columbia at times. Next slide, please. So periphyton has many forms, and just because you see periphyton, it doesn't necessarily mean you have cyanobacteria. So these are just examples of what you might see in a river or a lake nearby you. And some of these are organisms like filamentous green algae and don't produce toxin, but others um, can be toxin forming. Next slide, please. So as a health department, we were testing some reservoirs in our area. So we were familiar with planktonic blooms. We were sending samples in to get toxins and out analyzed. So we kind of were in the know about HAB, harmful algal blooms. But starting in the fall of 2021, and this is probably a familiar story to many of you that are working with benthics, and I know Hannah, who spoke last week, almost had this identical story, but we were contacted by a dog owner and a veterinarian that their dog had died after swimming in the Columbia River. And they took the dog to the veterinarian, and the veterinarian realized that these symptoms that the dog was having, it had convulsions, it was having difficulty breathing. Unfortunately, the dog had to be euthanized. Um, but the veterinarian recognized this as a potential of some sort of toxicity and was somewhat familiar with algal toxins. And it just so happened that he treated another dog the same weekend with similar symptoms. That dog had been swimming in the Columbia River as well. And so both the vet and the dog owner brought this to our attention. And then, in addition to that, there was quite a bit of um, the dog owner was quite upset. They spoke with the media, and then they did a story on the dog. And then when they ran the story on the dog, then there were other dog owners that came forward. So in all, during like about a 2 week period, 6 owners reported that their dogs became ill after swimming in the Columbia River, and 4 of those dogs died. And so this was quite unusual. We visited the Columbia where these dogs were swimming. We did not notice any sort of obvious um, planktonic bloom going on. We weren't really familiar with benthic algae, so we weren't quite sure what to do. But we contacted the State Department of Health, and they said, well, we should go ahead and sample the water because it could potentially be algal toxins. So we sampled the water, and long story short, we found very high levels of anatoxin where these dogs had reportedly been swimming. Next slide, please. And on this slide, we've got a few things going. So the first year, what I have in the orange circle there are a number of samplings we took. So you can see very high levels of anatoxin, at one point, almost 70 micrograms per liter of anatoxin in surface water. So at this point, I'd like to point out that our state has recreational thresholds set for cyanotoxins. And so in our state, the anatoxin recreational threshold for the recreational threshold for anatoxin is 1 microgram per liter. There is a drinking water standard as well. That drinking water standard is 0.3 micrograms per liter. So anyway, this was alarming to all of us. I already mentioned the Columbia River is the main drinking water source for the Tri-City area, which is a population of about 300,000 people. And so we implemented a routine water monitoring program, and this really developed in the following year, so in 2022. Because it was determined or thought that this was a benthic issue and that the benthic algae were not obvious to us when we went out and looked at the river. And so we just started implementing a routine water monitoring program. So we started monitoring about 6 recreation sites, and also the water treatment plants were taking water samples at their water intakes. And so anyway, we implemented that program really in 2022, and we've continued it since. And there's just some data that's shown here. Following 2021, we did not have any other dog deaths reported in 2022. In 2023, we had 3 more illnesses reported, resulting in 2 deaths, and fortunately, no deaths in 2024, 2025. Next slide, please. So sorry, the text is pretty small on this. I just want to point out that because we do this on a routine basis now, so we take water samples about every other week from now we do July through October, but initially we started in May. So on the x-axis is the time, and y-axis is the anatoxin A concentration. And there's kind of a general trend now that we've done this for multiple years is that really we don't see much antitoxin production until late July, and it starts rising in August. We have kind of a peak in September, and then it starts falling off as we progress later into the fall. We sometimes have some detections in October, but basically it falls off by November. And so this has now become our routine water monitoring program where we basically start monitoring in July and monitor through the first part of November. Next slide, please. So, like I say, none of us at the health district were experts on benthic bacteria. We would walk down to the river shore and multiple locations and find examples of what I've shown here on the slide. So in some instances, you find what appears to be something on the rocks. It's very ubiquitous. But it all looks the same. Nothing very unique about it. In other sites, you have a lot of green filamentous algae. In other areas, you have more of a golden brown periphyton that's growing on the rocks. And so it was very difficult for us to just walk down to the river shore and say, this is what's producing the antitoxin, and this is what we need to be looking for in the future. So this became kind of our goal was to try and identify, which periphyton on these rocks was creating the problem, or maybe all of it was. Next slide, please. And so I should point out that at this juncture is that I've been a biologist all my life, but I've really just studied algae within the last 3 to 4 years. So I'm fairly new to all of this. So it became kind of a whodunit, who's responsible for producing the antitoxin in this large stretch of river, and the characteristics of the river change. So ultimately, we're kind of looking at about 40 miles of river, so it's pretty vast. But so some of the first tools we looked at were available satellite data, and most of you have seen satellite data like this. The satellite is picking up chlorophyll in the river, and wherever you have these red signature spots is where there's a lot of photosynthesis going on. It's not necessarily indicating where benthics are, but you either have aquatic plants here or some sort of algae that's performing photosynthesis. And so we started looking at satellite imagery, and some areas lit up pretty well, and that's what I'm showing in this photo here. This has become one of our main study sites. Um, and so using satellite imagery became one of our tools. And next slide, please. And then as we started to work with other partners at USGS and the EPA, they brought instruments that were also helpful to us. I don't know if and many of you have heard of this bentho torch, but it basically shoots wavelengths of light into the periphyton. You actually take this instrument and hold it onto the rock where the periphyton is growing. It shoots multiple wavelengths of light into the algae or the cyanobacteria, the periphyton, basically. And then the chlorophylls, the different types of chlorophylls in the periphyton will absorb the light and then will also emit light. And then this detector or this instrument has a detector that will take the absorbance of that reflected light and analyze it. And it just so happens that diatoms have a slightly different wavelength that they emit at versus green algae versus cyanobacteria. So it's another tool that can kind of give you a feel for what organisms are in the periphyton and which might be the most common organisms in the periphyton. So next slide, please. So I know there's a lot on this slide. Just disregard, if you will, the small text. What I'm keying in here are just the photos. So we went to, say, this area where we saw the satellite data finding sort of hotspots, if you will. And we went to those areas and we would find multiple periphyton types. And so one of our goals was just to go out and start photographing these different phenotypes, if you will. Some were brown, some were green, some were rough. And so I have an example of each. So there's this brown variety, which we now think is Formidium or Microcoleus. There was also a green variety that looked very similar to the brown variety, but green. We still don't know whether this is a different species or just the same species that has different characteristics, one being brown, one being green. Another hypothesis is that uh, the green is perhaps a young version of the brown version. So it sort of starts out green, and then as the periphyton increases in thickness and stuff, it sort of turns a brown color. We don't know yet. But what I'm trying to point out is here we identified different types of periphyton on different rocks. And using the tool that I just described, the bentho torch, we would take readings from these. And here's an example on the right-hand side of the screen that shows some of what these readings are. And so when we would take readings from this sort of brown periphyton, it would indicate that there was a lot of cyanobacteria there and some diatoms. The green also indicated, or excuse me, the instrument also indicated that the greens also were largely cyanobacteria and some diatoms. And then this last one, which is actually probably the most common phenotype that we find, is almost exclusively diatoms. We do think that there are cyanos in this phenotype, and surprisingly enough, at times we will find the cyanos growing on top of these diatoms. But this is a good example of what kind of just the diatom morphology looks like, the morphology and phenology. In general, the diatoms are kind of golden in color. And then to the right of each of those photographs of the rocks, then we have what some of these microbes look like under the microscope. And the cyanobacteria are primarily filamentous cyanobacteria, and this makes their ID kind of complicated. In a lot of the planktonic algae, quite a few of the cells have very unique characteristics, which makes them kind of easy to identify from one another. But a lot of the benthics are filamentous, and the filamentous varieties look quite similar. It's very difficult to identify them just by microscopic examination. But what I've provided here is just some different views of what we see then when we look at them under a microscope. Diatoms have a very characteristic appearance. Most of you are probably familiar with diatoms, but they have this silicaceous sort of shell to them, and they have very unique shapes that the cells are. And so they're pretty easy. It's pretty easy to identify a diatom versus, say, a filamentous cyanobacteria. So next slide, please. So then we had a handle that we kind of knew what some of the cyanobacteria looked like on some of the rocks. And so we established some field research sites and then started doing things like harvesting the periphyton, and in many cases doing sort of a composite sample where we would go to a site and take photos of the rocks and then harvest periphyton um, in a very unique, or not unique, but a very quantitative type of fashion. Um, and then we would pool all the samples together, and then we can take it back to the lab. In our lab, we actually have a water lab at our health district, and we have the capability of performing an ELISA assay. And so we're able to take those composites, take them back to the lab, and do antitoxin testing on those periphyton samples. Next slide, please. And so here's some of the data we've generated so far. And if you look at the far right-hand column, the antitoxin concentration in this case was in nanograms per centimeter cube on the rock. You'll notice that we found very, very high levels of antitoxin in some areas. And these two top samples are of those samples that I showed, the green and brown varieties that I've been talking about. We took green and brown varieties specifically to kind of see if the green or the brown variety was producing more or less antitoxin, and it appears that it's producing about the same amount of antitoxin. We did check multiple sites along the river in about a 30 or 40-mile stretch. And what we found is that as you move closer to the Tri-Cities, the river becomes more like a reservoir. So the flows are not as substantial. There's more kind of sediment in the river as you move closer to the cities. And so what we're finding is that in certain upstream locations of the river, we're finding quite a bit of cyanobacteria, but as we move closer to the cities, we're finding less and less. And that's what's kind of shown here is that some of these sites like Island 17, WSU, Chewan, Columbia Point, these are all closer to the Tri-Cities. And even though some of the periphytons are producing limited amounts of antitoxin, they are by no means anywhere close to what we're seeing at further upstream locations. Also, in comparing upstream and downstream locations, it appears that when you take a rock from upstream, there's a lot of organics in it. It's primarily periphyton and sort of living organisms, if you will. There's a high organic content. Whereas when you move closer to the Tri-Cities, the periphyton, if you were to scrub it off and look at its content, it's more and more sediment and less organics. So if we were to go back to one of those original photos that I showed, I said that some of the rocks near the Tri-Cities just have this kind of like a ubiquitous kind of brown color to them. And more now, I'm thinking that that's just primarily sediments and silt that have settled out on the rocks, and it's less algae and more sediment. And there might be reasons for that, but I won't go into detail on that. So next slide, please. So another tool in our tool bag then was to actually put out spats. Most of you have probably heard about spats. They're solid phase absorption toxin tracking devices. And on the left, you see a photo of what our river looks like in this area where we're finding lots of these benthic cyanobacteria. So a very cobble type shoreline, very clear water. And so on the left there, you can see two spats that we've actually set in the river itself. And then on the right is what the spats kind of look like when we take them out. And I know there's lots of different researchers using different um, set out times. You know, some people only set out spats for a day, others do it for multiple weeks. We're using a fairly short span. About 7 days is what we've been doing. And so instead of a snapshot of antitoxin production in a surface water sample, this gives us a feel for antitoxin production over time at specific locations. And we're doing this at the upstream locations as well as the downstream locations. And once again, in the upstream locations that's shown in this photo here, we're finding lots of antitoxin production, whereas the closer we get to the Tri-Cities, we're finding less and less antitoxin production. Next slide, please. And so this is just kind of a nice wrap up slide of, how this progressed, how this all evolved. We used satellite imagery. We started to do some field work. We started just going out, taking photographs of different growth that we were seeing on the rocks. Started to look at it under the microscope. I'm not a benthic algae identification expert, but I did find an algae person that is very good at identifying cyanobacteria using microscopic, images. However, she's more of an expert in planktonic algae versus benthic algae, and I would probably say that there's not too many people that are really experts on benthic microscopy, just because, as I mentioned before, they don't have too many unique characteristics. But anyway, this is just an evolution of what we kind of did. Started with some satellite data, went out, started doing some field work, taking photos, looking at it under the microscope. And what's not shown here is then we're also analyzing it for these samples for antitoxin, putting out spats, which will give us more of a long-term, what is the long-term production of antitoxin in our area. Next slide, please. So in terms of health risk, this is what I think. Many of the locations closer to the Tri-Cities where we have our parks and we take surface water samples, there are times during the recreational season where where we'll get a surface water sample that's over the recreational threshold. And when that occurs, then we post signs like a warning, no swimming signs. But more and more, what I think is the major issue, and I think Hannah alluded to this last week, is that is the algal mats sloughing off of the rocks and then floating downstream. And this is just a photo of one of the sites, and this is typical of what we're seeing. So like this group of rocks where hopefully you can see my arrow, this group of rocks right here all have what we're calling microcoleus. The nomenclature is kind of up in the air right now, but Formidium and microcoleus are kind of being used interchangeably at this point. I think most people are moving to microcoleus as the name of this organism, that's this cyanobacteria that's growing. But what happens in the river system is, especially below the dam, is that they regulate the river up and down. And so water flows or water depths can change substantially depending on how much water they're releasing from the dam. And so some areas where this algae is growing can actually get stranded, and water temperatures can raise substantially. So that's what I'm showing here in this photo. I mean, in this photo, the water temperature nearby was about 64 degrees, but right here it's 81 degrees. And you can kind of see that there's some periphyte and lifting off of this rock here. And um, what happens then is as that algal mat sloughs off of that rocks, it's quite buoyant, primarily due to the fact they're photosynthesizing and there's trapped oxygen bubbles within the solid. They will float very easily and can float, many, many miles downstream. And so I think this is a part of the problem. And I think the greatest risk to humans and dogs in particular are these floating algal mats, because those mats, as they're dying, the cells are bursting open and they're releasing more and more toxins. So the floating mats, I think, are the biggest health hazard, and health risk to people and pets, particularly pets. Sometimes the dogs actually will eat these algal mats, just sampling things on the surface. And these algal mats, in my opinion, are loaded with anatoxin and can be very dangerous to dogs if they ingest them. Next slide, please. And so so interestingly enough, I've kind of characterized some of our sites as production sites versus accumulation sites. So in the right photo is just a nice chunk of benthic mat. And for those of you that are watching, don't pick up one of these mats with your bare hand because they're loaded with anatoxin. But anyway, this is an example of what these mats look like. And then the photo on your left is what I'm calling an accumulation site. So a lot of these mats are floating down the river, and in certain parts of the river, you can have like big eddies, and the current pulls these floating chunks in, and then they get sort of stranded, if you will, alongside of docks and other structures. And so then they're accumulating in these areas. And so this is a time bomb waiting to happen. So these are mats that are, and this is actually at a very popular park. And this dock here was actually what they called a swim dock. Long story short, this dock has been removed because of this very fact that these algal mats were accumulating here, and when we were taking surface water samples near these algal mats, the anatoxin level was very high. So we did get the city to remove this dock because lots of mats were accumulating here. Next slide, please. So, my final thoughts based on some limited field work, observations, and lab analysis, there's evidence that anatoxin producing cyanobacteria, what we believe are primarily microcoleus and formidium, is found throughout the Hanford Reach, but there are definitely appear to be hot spots. And those hot spots seem to be where the water is fast flowing and clear. And other research that I would say that the research that's going on in Northern California primarily, their benthic work there that I've read a lot of materials about it, but I think they are finding the same thing in a lot of their rivers, which share characteristics of the Columbia River. They're finding a lot of these in very fast moving clear water. So those are the hot spots in the Columbia. And as I mentioned before, as we move closer and closer to the Tri-Cities, the river becomes more like a reservoir and less like a fast moving river. The periphyton can lift off of the rocks as it dies or sloughs off as it just grows throughout the season, and that is what we call an algal mat. Those mats release high levels of anatoxins as the cells are lysing and dying, and then it is the mats that pose the greatest health risk to young children and dogs along the shoreline. Next slide, please. So this is a huge team effort. I've had a lot of help. The EPA and USGS are doing their own research. EPA did most of their research in 2024. And unfortunately, 2024 was not a very good toxin year, but EPA did a lot of sampling, and they're just now sort of getting through all their data, and hopefully they'll be releasing their results in the next year or so, and will complement some of the work that we've done. Next slide, please. Oh, sorry. While I'm on this slide, I definitely want to recognize the granting agency that's supporting this research. The research grant came from the Washington State Department of Ecology, and Joey Teresi is the grant manager there. Lots of other folks helped me, but we'll move on to the next slide, which should be uh, this presentation will go out. So I just provided some interesting, or what I thought were sort of pivotal articles on benthic algae. Most of you know that Susan Woods in New Zealand has really done a ton of work on these. So I highly recommend you reading these first couple of papers by Susan Wood, or Susan Wood is an author. And then there's some websites, some videos. Next slide, please. And then some other critical people that I've worked with that know a lot about benthics. So if the benthics are kind of new to you and you're just getting into them, these are some people that I consider experts in the benthic algae. So you might want to look them up if you are having issues. And I think, next slide, yeah, let's conclude there and answer any questions that might have come up.
Great. Thank you so much. Does anyone have any questions? You are welcome to either unmute yourself or you could put it in the chat if you do. I can start off. I noticed with your data that 2024 and 2025 didn't have any dog deaths, and I was curious, well, one, if there was any public outreach that was going out about kind of the benthic mats, and if that was informing why you were seeing less dog deaths
Yes,
there.
I'd like to think that I'm responsible there or the health district is partly responsible for no deaths in 2024 and 2025. Yes, we did lots of public outreach, and I kind of glossed over that. I'm kind of focusing on the research, but yes, we did a lot of that. and the state has implemented. The state last year produced new signage for the state that most of the typical signage you see is for planktonic blooms, and so they created a specific signage for benthic algae blooms. And something that I didn't really talk about is that last year was really just kind of our first year doing research, and that research will continue throughout this season as well. And so we're really kind of just starting this. But I think we've made pretty good progress already. I really feel like we know who's producing the antitoxin and kind of where it likes to grow best. Um,
Yeah. Follow-up question for that as well. How was the public reception on the outreach about benthic cyanobacteria? And because they are more difficult to identify too, so it's kind
right,
of
right. I would say it's definitely a challenge because so many people have seen all the images of planktonic blooms, and there's a lot of confusion over, some people see aquatic weeds and think that, those might be mats that are floating down. So yeah, I mean, it's definitely something difficult to educate people about it. But I talk to the media a lot, and they've been pretty generous of sharing stories. And whenever I talk, I really emphasize they need to look out for those floating mats is really the biggest health risk, in my opinion. So we have had some great media coverage in our area, and so I think it is working. People definitely know we have toxic algae. They don't always know what it looks like, but they're at least aware of it.
great. That's really helpful. Thank you. We do have a question in the chat. Someone said, I'm curious to know how far the benthic torch will reach during a sample. In other words, how many times do you have to press go in an area to complete a sample?
Good question. So you're just putting it on a rock, and it's best to take multiple samples from one rock, and kind of take an average, if you will. Or so yeah, it's best to move around the rock. Um, I don't know if part of that question is you basically don't hold it to the surface. You don't simply hold it to the surface of the water and shoot everything that's all the rocks below. It's very specific. You're on top of a rock, and the diameter of the kind of the light head is only about a centimeter in diameter.
I have a follow-up to that
Sure.
actually. How big is the benthic torch? When I saw it, I was imagining like 3 feet long, but it sounds like it
Uh,
might be smaller.
I would say it's 2 feet long.
Okay. Okay.
Unfortunately, they're very expensive. I think to get one is about $12,000. But for me, um, I talk to a lot of people. I have a lot of partnerships. So like this one is owned by the USGS, but they loaned it to us, or actually they brought it with them last year, and this year they're kind of loaning it to me for a while. So you might reach out if this is something that concerns you and you don't have the funds. You might reach out to universities or organizations like USGS, EPA. Perhaps they have a piece of equipment like this that they would loan you.
Any other questions that people would like to ask?
Hi, this is Jeff. I guess I'm more interested in the drinking water testing. Last week it was mentioned that the water was often better than the mats, which is encouraging. But how has the drinking water test come back?
Yeah, so far, so what we do is a raw water sample and a finished water sample. In the raw water samples, we've had very few detections, but when we do have a raw water sample above a certain threshold, then we actually have them follow up and immediately take another raw water sample and then a finished water sample from that source. And in all of the times we've done that, it's probably been about a half dozen times. We've never detected any antitoxins in the finished water sample. And I should point out when this all occurred, one of the city's water treatment plants had already been using sodium permanganate as a treatment. And if for those of you that don't know, that antitoxin is pretty resilient to other oxidants like chlorine, but sodium permanganate is fairly effective at treating antitoxin in drinking water. Um, since the initial date, 2021, the other two cities have added sodium permanganate to their water treatment systems. Um, However, they're still tweaking it a bit because initially their sodium permanganate injection ports were basically at the facility and there wasn't much of a contact time. They're now implementing sort of constructing injection ports right at the surface where it's basically coming out of the surface water. So it has more contact time with the water. So basically all three cities now have kind of basically, I would say, a good treatment for antitoxin.
Great. We do have another question in the chat. The toxins found in clear water is slightly confusing. Are they released from the mats upstream, and how are you able to detect them in clear water? I think by clear water, you're meaning clear water that the light could penetrate down to the bottom where the benthic mats are growing, correct? When you're referencing clear water.
Yeah.
Okay.
So I'm just saying that the clarity of the river is very clear in the areas where we're finding most of the benthics, whereas the closer you move to the Tri-Cities, there's more turbidity.
Yeah.
I'm not sure I answered the question.
No,
um,
I think yes, there is clear water down to where, and you're seeing the benthic mats kind of through that clear water. Am I correct?
Absolutely. Yeah,
Okay.
I would say the light visibility is probably at least 15 feet deep. But we're primarily concentrating, in wadeable water near the shorelines. That's the other thing. I mean, the Columbia River is a huge river, and so we're focusing along the shorelines and we're wading. I've been given some recent evidence recently that these algae are probably at a deeper level than I think they are. And so we're kind of exploring that possibility. But I mean, we're sort of focusing on wadable stretches of the shoreline.
Got it. Thank you. There is one other question in the mat, and then we are getting close to time. Do, and this is kind of building off of some of the public recognition, do other organisms create mats that might be confused with benthic mats, and are there best practices for public education on IDing mats that are likely to have toxins?
I would say it's pretty difficult determining what are cyanobacteria and not are cyanobacteria. I mean, it's taken me some time, and yeah, so I think there's a lot of room for confusion. Um, when I first started, I thought there weren't many visual like IDs for benthics, but I'm seeing more and more. But it is more challenging, I think, than just kind of showing somebody what a planktonic bloom looks like. I mean, And there's variety, although I will say that the microcoleus does seem to be very common in most river systems where they're having an issue. There are definitely other types of cyanobacteria, benthic cyanobacteria, that produce toxins that are not microcoleus. And yeah, I think they're far more difficult to identify, and you might actually have to use microscopy to identify them. So yeah, I think it's pretty difficult, especially when you have like a lot of diatoms on the rocks, really showing people what the difference is. And yeah, so I mean, I think there would be confusion trying to actually, show the public what benthic cyanobacteria look like. And it could be a little misleading too, because because there's a lot of paraphyton out there that aren't benthic cyanobacteria. So it's challenging.
Is
Yeah.
there time for me to ask a quick question about nutrients?
Sure.
Just anything about phosphorus levels or nitrogen or correlations with nutrients?
Um, Here's what I'll say about that. We have not investigated it. When EPA was here, they did a fairly thorough nutrient analysis. Like I said, their results aren't available yet, but I'll summarize them. And there's very low levels of nitrates and phosphorus in this area. In other reports of benthics in clear rivers like this, it seems to be the case that it's not an uptick of nutrients in these instances. These organisms are kind of creating their own nutrients in these thick periphyton mats, and other organisms might actually be generating some of the nutrients for the cyanos. But I will say this, the EPA data shows very few nitrates or phosphates in the water.
Great. Thank you so much. We are coming up on time, so I'm going to end the questions there, but I'm happy to share your email when we send out the video recordings as well as your slides. But we really just want to say thank you so much again for taking the time to come talk about benthic cyanobacteria, and I will be in touch with some questions as well. So
Okay.
awesome. Thank you so much,
Thanks for
everyone.
having me.